starting the new practical, that is estimation of oxalic acid by titrating with potassium permanganate solution by permanganometric method. Titration. Volumetric analysis is the analysis where quantitative estimation is carried out by measuring the volume of the solution and titrating it against a solution of known strength. Titration is the process of adding one solution of known strength from a burette to a known volume of another solution of an unknown strength until the reaction is just complete. This is the picture that's showing titration between KMnO4 solution versus oxalic acid solution in acidic medium. After addition of KMnO4 solution, at the end point, oxalic acid solution shows pale permanent pink color. Types of titrations: acidimetric and alkylimetric, oxidation reduction titration, iodometric and idimetric titration, precipitation and complexometric titration. Redox titration. In such type of titration, a reducing agent is estimated by titrating it with a standard oxidizing agent and vice versa. Generally, oxidizing agent is used as a standard solution. In these reactions, change in valency of ions takes place simultaneously. One substance is oxidized and other is reduced. Object of the titration: estimation of oxalic acid by titrating with potassium permanganate solution by permanganometric method. Prepare N by 30 oxalic acid standard solution and find out the strength of given oxalic acid solution using potassium permanganate as an intermediate solution. Apparatus and chemicals required: burette stand, burette clamp, burette of 50 ml, conical flask of 150 ml, pipette of 10 ml, beaker 250 ml, measuring flask 100 ml, test tube and test tube stand, spatula, dropper, digital wing balance, tripod stand, wire gauge, spirit lamp or Bunsen burner, matchbox. And the chemicals required are oxalic acid, potassium permanganate, dilute sulfuric acid. Lab preparation for teachers. As per requirement, teacher can prepare any strength of oxalic acid solution as well as KMnO4 solution. Theory behind this titration. Titration of oxalic acid with potassium permanganate solution in acidic medium is also a redox titration, in which oxalic acid acts as reducing agent and potassium permanganate as oxidizing agent in acidic medium. Here, KMnO4 gets reduced to colorless MnSO4 while oxalic acid gets oxidized to carbon dioxide. Therefore, contents of flask at end point are pink in color. Molecular reactions. Here, there is reaction of KMnO4 with sulfuric acid. It forms potassium sulfate, manganese sulfate, water and oxygen. Oxalic acid, which is hydrated in presence of oxygen, is converted into carbon dioxide and water. Overall reaction is when KMnO4 reacts with sulfuric acid and hydrated oxalic acid forms potassium sulfate, manganese sulfate, water and carbon dioxide. Ionic equation. Reduction half reaction where permanganate ion is converted into manganese ion. Oxidation half reaction where carbon is oxidized to carbon dioxide. Here, manganese ion is reduced to +7 oxidation state to +2 oxidation state. Procedure. Step 1. Titration of supplied oxalic acid solution, that is unknown solution with potassium permanganate solution. Rinse and fill the burette with potassium permanganate solution up to 0 mark. Pipette out 10 ml of supplied oxalic acid solution into a clean conical flask and add 2/3 test tube of dilute sulfuric acid. Heat the flask up to 70 to 80 degrees centigrade. In warm flask now, potassium permanganate solution is added from burette with continuous shaking till a light pink color appears. Last drop of potassium permanganate develops pink color. Hence, endpoint is just appearance of pink color. Note the reading of burette. First, rinse the burette with water. And then with potassium permanganate solution. Drain out this solution. Again fill the burette with potassium permanganate solution up to 0 mark. Maintain the level. Then tip it out. 10 ml of unknown oxalic acid solution. First, rinse the pipette with water. And then with unknown oxalic acid solution. After rinsing, drain out this solution. Then pipette out unknown oxalic acid solution. Into the conical flask. Conical flask should be cleaned properly. And then add 2/3 test tube of dilute sulfuric acid. Now warm this content up to 70 to 80 degrees centigrade. Heat the reaction content up to 70 to 80 degrees centigrade, and then again it titrate with KMnO4 solution. Add KMnO4 solution drop by drop into it. After adding KMnO4 solution, this transparent color changes into light pink color. Note the burette reading, it is of 7.8 ml. Repeat the procedure at least 2 times more until you get matching readings. Titration of unknown oxalic acid solution with KMnO4 solution. Volume of oxalic acid solution taken every time, that is 10 ml. Volume of KMnO4 used, that is burette reading, is 7.8, second reading is 7.7 ml and the third reading is 7.7 ml. Because of two readings are same, therefore final reading will be, that is V2 is 7.7 ml. Step 2. Preparation of standard oxalic acid solution of N by 30 strength. Equivalent weight of oxalic acid is 63. Amount of oxalic acid to be dissolved in 100 ml for N by 30 strength. The formula used is W is equal to NEV upon 1000. Input all the values of normality, equivalent weight and volume. The final result is 0.21 gram. So, weigh accurately approximately 0.21 gram of oxalic acid and pour into 100 ml measuring flask with the help of funnel. Now add distilled water to dissolve the oxalic acid and then make up the volume with distilled water up to the mark and shake well. Now prepare a standard solution of oxalic acid of N by 30 strength. For its preparation, first weigh 0.21 gram of oxalic acid by using the formula W is equal to NEV upon 1000. Now transfer this oxalic acid to 100 ml of measuring flask with the help of funnel. After adding oxalic acid, add little amount of water. Dissolve the oxalic acid and make up the volume by adding more water. Shake the solution. Now this is of standard oxalic acid solution of N by 30 strength. Titration of prepared oxalic acid solution, that is known solution with KMnO4 solution. Pipette out 10 ml of prepared oxalic acid solution into a conical flask. Now add 2/3 test tube of dilute sulfuric acid and heat the flask up to 70 to 80 degrees centigrade. In warm flask, add KMnO4 solution drop by drop from the burette with constant shaking until the color of the solution becomes pale pink. Note the burette reading when a permanent pale pink color appears. Repeat the experiment to get matching reading. Now pipette out 10 ml of known solution of oxalic acid. This is of 10 ml. Pour this oxalic acid solution to the conical flask and then again 2/3 test tube of dilute sulfuric acid. Heat the content up to 70 to 80 degrees centigrade. After heating, now again add potassium permanganate solution from the burette. Add KMnO4 solution drop by drop with constant shaking. Now this is the end point where transparent color changes into pink color. Note the reading, it is of 8.1 ml. Repeat the procedure at least 2 times more until you get concordant reading. Reading table. Titration of non-oxalic acid with KMnO4 solution. Volume of the oxalic acid solution taken for each reading is 10 ml. Volume of KMnO4 used, that is burette reading, is 8.1 ml. First reading, second reading is, and the third reading both are same, that is 7.9. So our final reading is 7.9, that is V1. Calculation. Formula used to calculate the strength of supplied oxalic acid solution is equal to 10 into W into V2 upon V1, where W is weight of oxalic acid is equal to 0.21 gram, V2 is equal to 7.7 and V1 is 7.9. Input all the values in the given formula. So our final result is the strength of supplied, that is unknown oxalic acid solution, is equal to dash gram per liter. Precautions during titration. During titration, operate the stopcock with the left hand and constantly swirl the flask with right hand. Rotate the titration flask throughout the titration to ensure the uniform distribution of potassium permanganate solution. No drop of solution should be at the tip of the burette at the end point. Read the upper meniscus while taking burette reading with potassium permanganate solution. Carefully fill the burette with the solution and see that the stopcock does not leak. Always keep the lower end of the pipette in the liquid when sucking it. OC questions. What is permagnometry? Permagnometry involves titration of reducing agent like oxalic acid with potassium permanganate that functions as an oxidizing agent in presence of dilute sulfuric acid. Second question, can KMnO4 titration be carried out in presence of nitric acid or hydrochloric acid? Answer is no, it cannot, because nitric acid itself being oxidizing agent interferes the oxidizing action of KMnO4. HCl reacts chemically with KMnO4 solution. What is oxidation number of manganese in KMnO4? Answer is, the oxidation number of manganese in KMnO4 is +7. Fourth question, why sulfuric acid is added in excess in KMnO4 titration? Answer is, sulfuric acid should be taken in excess to avoid formation of brown precipitates in MnO2. Question 5th, can KMnO4 titration be carried out in presence of concentrated sulfuric acid? Answer is no. The KMnO4 titrations should be carried out in the presence of dilute sulfuric acid only, as concentrated sulfuric acid is oxidizing agent itself. Question 6th, what normality of KMnO4 is prepared only on dissolving 3.16 gram of it in 1 liter? Answer is equivalent weight of KMnO4 is equal to 31.6. Use the formula W is equal to NEV upon 1000. Input all the values and we get the answer 0.1 normal. Question 7. Why sometimes the color of the solution turns brown on adding KMnO4 to oxalic acid solution? Answer is it is either due to rapid addition of KMnO4 solution to oxalic acid or in the presence of insufficient amount of dilute sulfuric acid, a brown color or precipitate of hydrated manganese dioxide is formed. Question 8. How many types of indicators are there? Answer is indicators are of three main types: internal indicator, external indicator, self-indicator. Question 9. What is molar solution? Answer is molar solution is that solution whose 1 liter contains 1 gram molecular weight of any substance dissolved in it. It is represented by capital M. Question 10. What is the relation between normality and strength? Answer is normality is equal to strength upon equivalent weight. How to write a practical in a practical file? First write object, then write apparatus and chemicals required. Then write theory of titration with reactions. Now fourth step will be procedure. Write all three steps of the titration. Next will be to prepare reading table and write formula for the calculation. Lastly, write results and the precautions. Thank you for watching this video. If you like this video, please share and subscribe the channel.